So let's see the circles, what are the questions that is there for JE, and let's try to solve those. So here's the first question. So then this is x squared. You know the center of the first circle is 9 and minus 15, so plus 15 by 2, and this happens to be the center of the circle. And the radius of the first circle is, this is minus g and minus f are the centers, so root of g square plus f square minus c, it is minus 131, because c is 131, g square plus f square minus c is r. So when you take LCM as 4 ones are 4, it was 32, plus 225 minus 4 ones are 4 3 is 12, 4 ones are 524 by 4, which itself is 225 by 4, which is 15 by 2. That happens to be radius r1. Let's go to the next circle. What is the center of the second circle? It's 3 and 3 are the centers, and radius, which is minus g and minus f, root of g square plus f square minus r square minus c, sorry, r is equal to root of g square plus f square minus c, which is plus 7, which is root of 25. So you know r2 is equal to 5. Now you got the two circles, center and the radius. Let's find the distance between the two centers, which is root of 9 minus 3 the whole square plus 15 by 2 minus 3 the whole square, which is 36 plus 15 minus 6 is 9, 81 by 4. So when you take LCM, 6 4s are 24, 3 is 12, 144 plus 81 by 4, which itself is 5 to 225 by 4, which is 15 by 2. So then if you add both the radius r1 plus r2, the distance between the two centers is equal to r1 plus r2. If that is the case, then the two circles are like this distance, which means that how many common tangent can be drawn is the question. 1 2 3 common tangent can be drawn. What are the other conditions that you should know of? If D happens to be greater than r1 plus r2, then the two circles are detached circles where D is this whole distance, which is greater than r1 plus r2. So you can draw common tangents such as 1 2 3 4 if that is the case. Okay, and similarly when D is lesser than r1 plus r2, then which means it is like this, and so you can have one common tangent. And when D is lesser than r1 minus r2, then it is like this, and so it's not no common tangent will be there. These are the conditions that you should be aware of. So let's go to the next question. So therefore in this, it's the three tangents are possible, so answer has to be C, which is, yeah. So let's go to the next question. Next question is this. Let the center of the circle be alpha comma beta, where r is less than 8. Let 3x plus 4y is equal to 24 and 3x minus 4y is equal to 32 be the two tangents. So you have one tangent which is 3x plus 4y is equal to 24, another tangent which is 3x minus 4y is equal to 32, and 4x plus 3y is equal to 1 be the normal at C. So the normal is, every radius will act as a normal, as you know. Okay, so the normal's line itself is 4x plus 3y is equal to 1. They have given it like that. Okay, then you have to find what is alpha minus beta plus r. Okay, so you know that you can imagine one normal and one tangent. If you can solve these one normal and one tangent, so let's take this as 3x plus 4y is equal to 24, or we can even take it as 3x minus 4y is equal to 32, whichever this line is. You can find the point of intersection, and so then that's my first thought. So let's take one of the lines. There's also one more tangent. There are two tangents as given, like that you can find this point of intersection too. But you know that the center is going to pass through the normal, 4x plus 3y. So on substituting alpha and beta, you get 4 alpha plus 3 beta is equal to 1. So you can write 3 beta is equal to 1 minus 4 alpha, a beta is equal to 1 minus 4 alpha by 3. Thus you can write alpha and beta as alpha and 1 minus 4 alpha by 3. This will be the center. Now let's, now that you got the center points, um, you know the center point, you have this equation, you can find this perpendicular distance, and you have this equation which is 3x plus 4y is equal to 24, and you can use the center point, find the distance, and this distance has got to be the same because both of them are r. So let's do the perpendicular distance formula. 3 into alpha plus 4 into 1 minus 4 alpha by 3 is equal to minus 24. Ax1 plus by1 plus c by root of a square plus b square is root of 9 plus 16, which is 25, which will be 5, which will also be equal to 3 into alpha minus 4 into 1 minus 4 alpha by 3 minus 32 by a root of 25. This and this get cancelled. The magnitude of this should be equal to magnitude of this because both of them have the same radius. So it's 3 alpha plus 4 by 3 minus 16 alpha by 3 minus 24 is equal to 3 alpha minus 4 by 3 plus 16 alpha by 3 minus 32. Bringing the alpha to one side, 3 alpha and 3 alpha directly get cancelled. This when brought to that side, 32 alpha by 3. Let the numbers, this is 4 by 3, minus 4 by 3 and 4 by 3 will become an 8 by 3. You have a minus 24 plus 32 remaining. So when you solve the left hand side, you know this itself is like 8. So 8 by 3 minus 8, it is equal to 32 alpha by 3. 8 can be taken out common. And 1 by 3 minus 1 is equal to 32 alpha by 3. 8 4s are 32. Let's take LCM. Minus 2 by 3 is equal to 4 alpha by 3. 3 and 3 get cancelled. So alpha is equal to minus 1 by 2. Getting alpha to be minus 1 by 2. I'm not sure if that's the right answer. So let's see. He's got alpha to be 1. What is the mistake? 3 into alpha. 4 into 1 minus 4 alpha by 3 minus 32. Everything is perfect. On solving this, I'm getting a different answer. That's the problem. 4 by 3, taking it inside, just see 4 by 3 plus minus 16 alpha by 3 is equal to minus 4 by 3 plus 16 alpha by 3 minus 32. 3 alpha gets cancelled. 4 by 3 and minus 4 by 3 will add up to 8 by 3. 16 alpha by 2 could the other side become 32 alpha by 3. Yeah. You have minus 24 plus 32, which is plus 8. I'm sorry. There has to be plus 8. So you take 8 out. So you got the answer, I think. So this will become 4 by 3 is equal to 4 alpha by 3. 3 and 3 get cancelled. So alpha is equal to 1. Once you get alpha, you know what is beta. It's 1 minus 4 alpha by 3. Beta is 1 minus 4 alpha, which is 1 by 3, which is minus 3 by 3, so minus 1. So you know alpha is equal to 1 and beta is equal to minus 1. Once you get that, now that you got the centers itself, if you know one of the point of intersection, which is a point of intersection between a line and the normal. So let's take one line and the normal. Let's take 4x plus 3y is equal to 1 and 3x minus 4y is equal to 32. Multiplying this entire equation with 3 and this entire equation with 4, it will become 12x plus 9y is equal to 3 and 12x minus 16y is equal to 4 2s are 8, 4 3s are 12. So it is minus plus and minus. So it will become 25y is equal to minus 125. So y is equal to minus 5. Substituting in one of the equation, you get what is x, and thus you get the point of intersection. So y is minus 5. Substitute in any of the equations. 4x plus 3y is equal to 1. So a 4x plus 3y is equal to 1. You just now found that what did you find? You found y is equal to minus 5. So it's 4x minus 15 is equal to 1. 4x is equal to 16, so x is equal to 4. So thus you know 4 comma minus 5 is this point. So you know the center alpha and beta, we just found it to be 1 comma minus 1. So let's find the distance between these two, which is x2 minus x1 the whole square plus y2 minus y1 the whole square. It's 925, root of 25, so therefore it's 5. So then the radius is 5 units, center is 1 comma minus 1. Center is 1 comma minus 1 and the radius is 5 units. And suppose you want the equation of the, so you know what is alpha, you know what is beta, and you know r. Just a question of substituting alpha minus beta plus r was what they're asking. 1 plus 1 plus 5, so answer is 7. So that answers this question. Let's go to the next one. The next question is, let A be the point 1 comma 2 and B be any point on the curve. So you know that this is 4 comma 0 0 comma 4, that's a circle, x square plus y square is equal to 16. Let A be any point 1 comma 2 will probably be here, and B be any point on the curve, and let's join this line segment AB. There is a point P which divides it at the ratio 3:2. Okay, so you know that the point A is 1 comma 2. You don't know what is the point, but you know any point on the circle is r cos theta comma, so it's 4 cos theta comma 4 sin theta. So let's take this line separately, which is A, and this line is B. You have 1 comma 2 and this is 4 cos theta comma 4 sin theta. A point P divides it in the ratio 3:2. Let's find what is 3 therefore. P therefore, m into x2, m into x2 plus n into x1 by m plus n will be the x coordinate of P, and the y coordinate of P is m into y2 plus n into y1 by m plus n. So what is it if you calculate? Okay, we consider it as x and y. Let's consider it as h and k to be the point P. See, let's consider it as h and k. So therefore, you know 12 cos theta plus 2 is equal to 5h. Cos theta is equal to 5h minus 2 by 12. Similarly, let's find sin theta. 12 sin theta plus 4 by 5 is equal to k. So therefore, sin theta is equal to 5k minus 4 by 12. So therefore, you know sin square theta plus cos square theta is equal to 1. So 5k minus 4 by 12 the whole square plus 5h minus 2 by 12 the whole square is equal to 1. So on expanding, you will get one equation with h and k. With the, which is 25k square minus 40k plus 16 by 144 plus 25h square minus 20h plus 4 is equal to 144. So 25k square plus 25h square minus 40k minus 20h, this will be 20 minus 124 is equal to 0. So thus we got an equation which is a circle's equation passing through h and k, which is nothing but the locus of the point P. The point P is h and k, so thus we got the locus of the point, which turns out to be a circle. So if the center of this is alpha comma beta, let's find the center of this. This itself is like an equation of a circle. You can find the center of the circle by dividing 2 odd beta 25. 40 by 25, 8 5 7, 8 by 5 minus 8 by 5k minus 20 by 25, which is 4 by 5 h minus 124 by 25 is equal to 0 is the equation of the circle, of that circle which is passing through the point P. And you know therefore the center of that will be 4 by 5 with a positive sign and a 2 by 5. So thus you know that the alpha and beta which are given to be the centers are 4 by 5 and 2 by 5. So we found alpha and beta. Now find the length of segment AC. Where is A? Where is C? C is a C is the center of that some other circle which is a locus of the point P. So that center is only alpha comma beta and the distance between 1 comma 2 and the alpha comma beta. So the 1 comma 2 and alpha comma beta, the distance of this will be a 4 by 5 minus 1 the whole square plus a 2 by 5 minus 2 the whole square, which is minus 5. So minus 1 by 5, 1 by 25 plus 5 2s are 10. So it will be minus 8 by 5, which is 64 by 25, which is root of 65 by 25, which is root 65 by 5. Let's see if what I've done is correct. 5, LCM is 5. 4 minus 5 is minus 1 by 5. It's 1 by 25. This will be 10, so 8 by 5. Let's verify my answer. See if any calculation mistake is there. Root 45 by 45. Why is that I'm getting? Is this point correct? Is the point 1 and 2 and 2 by 5 and 4 by 5? I think I have messed up here. It's h and k. So I need to, it has to be k square plus h square minus 4 by 5. So the centers have to be interchanged. It's 2 by 5 and a 4 by 5. Oh God. Okay, so 2 by 5 and a 4 by 5. So when you do the distance of this is root of 2 by 5 minus 1 the whole square plus 4 by 5 minus 1 the whole square. Now I think it will be sorted. It will be 3, so 9 by 25 plus 1 by 25. This is 4 by 5 minus 2. 2 by 5 minus 1, 4 by 5 minus 2. So it's 5 2s are 10. 10 minus 4 is 6, 36. So root of 45 by 25. So it's root 45 by 5. Root 45 by 5 is nothing but 9 5s are 45. So 3 root 5 by 5. So I hope you understood. I'm making calculation mistakes. Please ensure that you're correcting them. So let's go to the next question. The line segment AB of length lambda such that the point A and B remains on the periphery of the circle of radius lambda. The radius of the circle is also lambda, which means you're getting an equilateral triangle. Okay. Then the locus of the point P that divides the line segment AB in the ratio 2:3 is a circle. So I have to find the locus of the point P. See, normally what should I say? We can identify this point as r cos theta, r sin theta, but I cannot do that because there are two unknown points, so there's no point. In the previous sum, there's only one unknown point, the other point was known. So then, therefore, if you're going to construct an altitude like this, the chord and the center bisects the chord perpendicular, so then there will be an M here. And that will, dividing this part as lambda by 2 and lambda by 2. Now we can join the center with P so that you get a right angle triangle here, and you know that you can write OP square is equal to OM square plus MP square. And what is OM square? OM square, this is lambda, this is lambda by 2, hence you can find what is OM square, which is root of lambda square minus lambda square by 4, which is 3 lambda square by 4, which is root 3 by 2 lambda. So I need OM square, which is 3 lambda square by 4 plus I need MP. And what is MP? Can I write MP as AM minus AP, where AM itself is lambda by 2 minus AP. AP is 2 by 5 of lambda. So then can I write like this? Lambda by 2 minus 2 by 5 of lambda. So then that will give me my OP square. That will give me my OP square. Considering the point P to be H comma K, and this being a right triangle, you can also write it as H square plus K square is equal to, this is 3 lambda square by 4 plus, you solve this, lambda by 2 minus 10 is the LCM, so 5 lambda minus 4 lambda. So then it's 3 lambda square by 4 . So let me try whatever it's worth, and it will be a lambda by 10 is S square plus K square. Then the locus of the point, okay, this seems to be like locus, but what about R square? So is what I'm getting. Let's see what he has done. Then this the whole square, I'm sorry, again another mistake here. So then therefore this will be lambda square by 100. So thus you get this, and you can solve this to H square plus K square is equal to, you can solve this, this is 25 fours are, so 75 lambda square plus lambda square. So H square plus K square is equal to 76 lambda square by 100. So H and K are the centers where it can also be replaced as X and Y. Thus you get this to be the radius, which is root 76 by 10 into lambda will be the radius. 76, 3 to 6, 8 to 16, 2, 14, 2, 7. So can I write 2 root 21 by 10 lambda will be the radius. 76 lambda square by they have just factorized this. So you get 19, this becomes 25. So cancelling with the 4 tables. So you get H square plus K square is equal to 19 lambda square by 25, which will be the locus of the point P. So then the radius therefore is root 19 lambda by 5. The question is about radius. So you understand this kind of locus sums, and this was quite tricky. But what happens if I assume the point A as r cos theta, but I don't know what is the radius itself. The other sum I knew what is the radius, so then there's no way I could only solve the sum like this. Okay, so let's go to next question. Such a beautiful sum. Let O be the origin. OP and OQ be the tangents to a circle. Okay, so let O be the origin, and OP and OQ be the tangents to some random circle whose center is 3, minus 2, whose radius is G square plus F square minus R square, minus C. Root of 13 minus 8, so root 5. So you know radius itself is root 5, you know the center. Okay, if the circumcircle of the triangle OPQ passes through the point, circumcircle, so OPQ, just join P and Q, you have a triangle OPQ, and there is going to be a circle which passes through this. So when you do this, you should know that these two are this is a chord which is in contact with the tangents, and so then therefore you should assume that this is passing through 3, 2. Therefore the ends of the diameters are 0, 0 and 3, -2. You can, when you have the two opposite diameter points, you can write the equation of the circle. Supposing this is x1, y1 and this is x2, y2, the points, then the equation of the circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2. So then therefore you're going to write x minus 0 into x minus 3 plus y minus 0, which is just y, into y plus 2 is equal to 0. Thus the equation will become x square minus 3x plus y square plus 2y is equal to 0. So thus you get an equation like this, which is x square plus y square minus 3x plus 2y is equal to 0. Therefore the center of the circle will be plus 3 by 2 and a 1. That will be the center of this circle. And we got the locus, we got the circumcircle of which is passing through PQ, and we got the center. Now what is it? It's passing through the point alpha comma 1 by 2. So then the point, this, since the new circle passes through it, alpha square plus 1 by 4 minus 3 alpha plus 1 is equal to 0. So alpha square minus 3 alpha plus 5 by 4 is equal to 0. 4 alpha square minus 12 alpha plus 5 is equal to 0. Hence I think we are trying to find alpha. 5 4s are 20. You should get 12. 10 2s are 20. 4 alpha square minus 10 alpha minus 2 alpha plus 5 is equal to 0. So then from this 2 alpha into 2 alpha minus 5 minus 1 into 2 alpha minus 5. So a 2 alpha minus 1 and a 2 alpha minus 5 is equal to 0. So alpha is equal to 1 by 2, alpha is equal to 5 by 2. And you have an option C. So option C is the right answer. Superb. So let's go to next question. The next question is this. If the tangent at the point P and Q on a circle, this is a circle, this is a tangent at P and Q, they both are meeting at R, which is 9 by 4 comma 2. Then the area of triangle PQR. Okay. So then you know the original circle center will be a 1 and a minus 1 by 2. And what will be the radius of this? Radius, for whatever it's worth, I'm just finding root of g square plus f square minus c root of 1 by 4 minus 1, which is what? Cannot be negative. Something is wrong. The center is 1 and minus 1 by 2. G square plus f square minus c minus 5 will become plus 5. So root of 6. Okay, so 4 will be the LCM. Have 4 plus 1 plus 20. So it's 25. 5 by 2. So radius is 2.5. Whatever is worth, I found that. Now what is that we want? Find the area of triangle PQR. So whenever they give you, they ask you for area of a triangle, area of the triangle PQR, you know, you can do a circle using this, which obviously will pass through that. That's not it. You can, if you can remember the direct formula for finding the area of triangle PQR in such situations, where it's R into L cube by R square plus L square. This is the formula. R is the radius, L is the length of the tangent. Okay. So this will be the area. But how did they get this? Okay, hope they have got it. Let us see. See, let's construct this and let's mark this here. And if supposing this angle is alpha, this angle will also alpha by 90 degree and a 90 degree and similar triangles. So then if you want to find the length, this is length and this is r. Okay, so you have two triangles here and here. So then you are going to take, you want to find L. You can write cos alpha, you can write cos alpha. You can't, you have to write sin alpha, right? As sin alpha from this right triangle, as sin alpha is this length of half the length of the chord, or yeah, because PQ is not a diameter. It's just a chord. Okay, it's just a chord here. So then therefore you can say that if you write cos alpha, you'll have an adjacent side. Okay, so you write sin alpha, you get the opposite by L. So opposite side itself is L sin alpha. Okay, and what about taking this triangle here? You know cos alpha is equal to adjacent side by R. So adjacent is R cos alpha. So you know that this is R cos alpha. Okay, you know this is R cos alpha. And considering it's half into base into height, half into base is 2R cos alpha into height. So you should have done from the bigger triangle here, you should have done a cos alpha which will give you the height of the triangle by L. So height itself is L cos alpha. So substituting here L cos alpha. So 2 and 2 get cancelled. R L cos square alpha. And a cos alpha itself is what is cos alpha? Cos alpha itself is so you get R by, okay, what is cos alpha? Adjacent by hypotenuse. Adjacent by hypotenuse. Cos square alpha and a cos alpha from this, let's take this entire triangle. In that case this will be 90 degree. In that case cos alpha, you know that it's L square plus, this itself is root of L square plus R square. And so cos alpha is equal to, can I say L by, so L by L square plus R square, so R L cube. Yeah, by, so with using all these triangles you get this formula. Let's memorize this formula to find the area of the triangle. The formula is R into L square by R square plus L square, where L is the length of the tangent. How do you find the length of the tangent? I'm going to tell you the length of the tangent is also a square root of the equation of the circle. Okay, what is the equation of the circle? Okay, that at that point, which is passing through the point 9 by 4 comma 2. So let's substitute x square plus y square minus 2x plus y minus 5 is equal to 0. So it will be 81 by 16 plus 4 minus 18 by 4 plus 2 minus 5. And that will give you your length, that will give you your A root of this will give you your length. So then what is the root of this? Let's try to solve it. 81 by 16 minus 18 by 4. This is 6. 6 minus 5 is 1. Let's have LCM as 16 into 4. So 81 minus 8 4s are 32. 4 1s are 72 plus 4. And so this itself is 9 plus 4 is 13 by 16. I don't know what I'm doing is right or not. Okay. I'm trying to find the length. To finding the length, I'm just substituting in the equation of the circle. And this answer that I've got is wrong. It has to be 5 by 4. So there's a calculation mistake. Minus 2 in 9 by 4 plus 2 minus 5. Calculation mistake. Again, let's solve it. 81 by 16 minus 18 by 4. This is 6. 6 minus 5 is plus 1. Taking LCM to be 16 into 4. But into 16. Oh, sorry. So 81 minus 8 4s are 32. 72 plus 16. So this itself is 11 minus 2 is 9. 9 plus 16 is 25 by 16, which is 5 by 4. So I got the length of the tangent. So therefore, to find the length of the tangent which is passing through a point for a given circle, both the tangents will be of equal length by congruency. And so then to find the length, you can just square root the circle's equation. So you get L to be 5 by 4. Once you get the length, you can substitute in the formula. The area of the triangle is R into L cube by R square plus L square, right? R square plus L square. So R itself, I think I found R to be 5 by 2. Initially itself I found R to be 5 by 2. Into L cube is 5 cube by 4 cube by R square plus L square. 25 by 4 plus L square is 25 by 4. What? R is 5 by 2. 25 by 4 is 25 by 16. So it will be 5 to the power 4 by 4 to the power 3 into 2 by LCM 16, 125 by 16. So how do I solve this? So this itself is 125, which is 5 5 25 25 5 is 125 5 cube. So this and this get cancelled. This can be written as 4 square, and the 4 square and the 4 cube will get cancelled. So I'm getting 5 by 8. And that becomes the area. So if you can remember this, you can avoid half into base into height and all that. Just a question of L can be found out immediately. You don't need to derive the formula. I'm just teaching you, but if you can memorize the formula, the answer becomes very, very easy. So let's go to the next question. The set of all values of a square. Okay, so let me break with this and then continue in the next video.